All right, so our problem now is dealing with a definite integral using a substitution rule. Now, I've got a nice one here. I took the indefinite integral we had last time and slapped some really nice numbers. 1 and 5 are really nice numbers. You should meet them sometime. But right off the bat, I'm kind of using this as an example to point out that I can't do that indefinite integral. That if you actually go cranking through this using the technique I'm going to show you, you would get numbers and you would be wrong. Wrong, 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 wrong. Why is that? Think about it. Because any definite integral, we have the assumption that over the closed interval that we're computing this, that the integrand is integrable. Actually, we assume that it's continuous. Now, just think about, where is this thing defined? What is the domain of this thing? Why do you spend so much time talking about the domain of these things? Here, let me plot something for you. Let's plot this thing, this integrand here. That's what I mean when I keep saying integrand. You should know, but now you'll know. Oh, craziness I am. And I'm going to go from like -3 to 3. Let's see what it does. Look. See? Now these lines are just figmentations. They're not really there. It's the grapher jumping, but we have discontinuities at 2 and -2. You can't integrate from 1 to 5 and even we've got some work to do. These are improper integrals. We have some work to do if we want to try to integrate and figure out what this area is, if any. It might be an infinite amount of area. So just want to point out that you have to be careful. You can't just put any old numbers up here and use that technique and that the number that comes out will make any sense whatsoever. So let's try 3. 3 avoids the problem. 3 to 5, everything's good down here. All is happy. It's a continuous function, so we know we can get the area between the curve, the directed area between the curve and the axis. Okay, so let's see here. We've got this, and we know how to do this from last time. U4 minus x squared du minus 2x. I'm getting ready to change that, so I stick this stuff in, I pull the x down, all those good things. But there's 2 things you can do here. Right now, I'm going to remind us that these 3 and 5s are in terms of x. It's x equals 3 and x equals 5, so I have 2 choices. I can complete the antiderivative here, do the back substitution for u back into x, and then stick in 3 or 5. I wouldn't recommend that. You can. Or I could go ahead and transform the 3 or 5 into the u world. What are those numbers in terms of u? Now, how would I do that? Well, I can do them in my head, but I might as well show you how you can do it in Mathematica. So if we got 4 minus x squared, 4 minus x squared, and we want to know is, we'll do substitution. So we're going to replace the x with a list of things. We're going to replace it with 3 and 5. And let's see what the value, because remember, this is u. So if x is 3, we're going to find out what u is. When x is 5, we're going to find out what u is. Minus 5 and 21. All right, so what does that mean? Well, that means that this x equals 5 and this x equals 3, we can actually write them in terms of u. We're integrating this thing with respect to u from minus 5 to minus 21, and we know how to do that. Natural log absolute value from minus 5 to minus 21. We plug those in and take the difference, and then we use properties of logarithms, and we get this right here. Now, let's see real quick, let's just see what the integral would have done for us. Integrate x over 4 minus x squared, right? Now, how would we have done this? X comma 3 comma 5. Let's see what it does. Took it a while. I think I could have beat it. I could have. But it's still beautiful stuff. I hope that helps. We're going to do, after this, That's it for this stuff. You can go look at Mr. Thoreau's work or someone else's work, and if you have any suggestions, there are lots of work in the text, but I think we're going to do look at the product rule and see how it can help us out. Okay, see you in the next video.